Hi, in this video we are going to discuss about two more metrics. In the previous video we are discussed about the precision, recall, accuracy and AUC log loss. Those are basically for the classification task. Precision, accuracy, precision, recall, F1 score, AUC and log loss. These are we can use for the classification task. Generally, along with the classification, we have also regression task. To get the best model, we are also need the a metric for the regression model. Also, we have few metrics are there. In this video, we are going to discuss most commonly used metrics. Those two are R squared and mean absolute percentage error. And also, mostly we are also used square error. For the regression task, we have the R squared mean absolute percentage error and mean square error. In this video, we will discuss about these two things. And the mean square error, I think we already know. In the previous videos, we have discussed about the mean square error. Let's start with R square. R square equal to 1 minus SS residual by the SS total. Let's see these two terminologies. What is the SS residual? SS residual. Suppose we have a data. Let's consider x is the futures and y is the values, and the predicted from the model is y hat. Let's consider like that. The x1, x2, x3, those are the input features, and the output regression values y1, y2, y3. These are the actual values, and the predicted from the model is y1 hat, y2 hat, y3 hat. Let's consider like that. Here SS residual is equal to 1 by n sigma I equal to 1 to n ya minus y hat whole square. This is like a square error with model. From the model we will get the values, and those values and the actual value we will take the square error, that is the SS residual. And the SS total will equal to 1 by n sigma I equal to 1 to n yi minus y bar whole square. Here y bar is equal to the mean of ya. The mean of these values is going to be the y hat. Y bar. This is the SS residual and SS total. Let's see few more things about the R square. The maximum value for the R square is going to be 1. When it will be happen is when the SS residual is going to be 0. SS residual is the actual from the model we will getting. If the model is going to be perfect, then only this value is going to be 0. Then we can tell if the R square of the model is going to be 1, then we can tell the model is going to be a perfect model. If R square is lies between 0 to 1, it will be happen only these values between the 0 to 1. At the time we are going to get the R square value is going to be 0 to 1. It will be happen when the SS residual is going to be, here SS residual is going to be 0. Here SS residual is less than SS total. The total error means square error that we get from the model is less than the from the mean model. This in this scenario we can tell the model is going to be a good model. If R square equal to 0, when it will be happen when these two are equal to be same, at the time the value is going to be 1 minus 1 is going to be 0. That means SS residual is equal to the SS total. This model is like a random model. if r square is less than 0. When it will be happen? When ss residual is going to be greater than ss total. That means the error that we are getting is greater than the from the normal mean model. SS residual is greater than SS total. This in this scenario we can tell this model is going to be the worst model. Yeah, when r square equal to 1, we can tell that model is good to be a good model. That is a perfect model. If the value lies between 0 to 1 for a model, we can tell that model is good model. If the value is r square equal to 0, that is like a random model. It's less than 0 is a worst case scenario. This one. Maybe mean absolute percentage error. Here we can its formula is like this, and we can also use if you want 100. Okay, maybe equal to 1 by n, sigma equal to 1 to n by n is the actual value. This is the actual value, and these are the predicted by the actual. By this way, we will get the maybe is 0 to 1. We can tell if the value is close to 0, then we can tell the model is going to be very good model. If it is close to 1, we can tell that model going to be the worst model. There is just some scenarios. At that time, we also get MAP score greater than 1 also. The scenario is like this. If the actual value is low and the predicted value is going to be very high. This is absolute. Okay, we have to take absolute here. If the value is very high, predicted value at the time, this is more dominant, and by this way we will get like that. For suppose if y had predicted is less than 2 times so of y, 2 times of y, at that time we will get the MAP score is greater than 1. This is the one